So in this video we're going to look at solving equations that have a radical in them or a square root. And the technique that we're going to have to do is raising both sides to the same power. In this case we'll be raising each side to the second power or squaring both sides. Whenever we have to raise both sides of an equation in the solution process, we always run the risk of introducing extraneous solutions, or in other words, we run the risk of introducing solutions that weren't solutions to the original equation. So we always have to check when we get done to make sure that the answer we have actually works in the original equation. So with a radical equation, here I have a single radical or square root symbol. The idea is that you want to isolate the radical on one side of the equation. So I'm going to rewrite the original equation. And in this case we want to isolate the square root symbol so that it's by itself. So what we could do is add x to both sides. So if I do that, I would get x. I would add x to both sides. I'll have an x minus 3 on the left side, and I'll have the square root of negative 5x plus 39 on the right hand side. And then to eliminate the square root, we would square both sides. And if we square this out, we get x squared minus 6x plus 9. And over here, the squaring would cancel the square rooting and leave us with a minus 5x plus 39. Remember to square a binomial. If you have x minus 3 squared, the squaring means take the binomial, that's the base, and multiply it by itself. So you're just using the distributive property. X times x is x squared. X times minus 3 is minus 3x. Minus 3 times x is minus 3x. And minus 3 times minus 3 is plus 9. And you get the middle twice when you square a binomial out. So you wind up getting two of the middle terms. So you get the minus 6x plus 9 that we had here. So to get the minus 6, what I did is I said, hey, I'm going to be multiplying a minus 3 times x to get minus 3x, but that's going to happen twice, so you just double that to get the negative 6. So once I have squared both sides, I want to look at this carefully and recognize that I have an equation that we've already dealt with this semester. We have a quadratic equation. I know that because I have a single variable and the largest exponent showing up on the variable is a 2. I have all whole number exponents. I have x to the first, x squared. So this is just a quadratic equation. So we know that one solution technique is to get it equal to 0 and see if we can factor it. So to do that, I could take and add 5x to both sides. So I'd get minus 6x plus 5x would be minus x. And then we could subtract 39 from both sides. So 9 minus 39 would be a minus 30. And then if the leading coefficient is a 1, it's usually fairly easy to try to guess. If it factors easily, usually you can guess the factorization. So in this case, it looks like a minus 6 and a plus 5. And to check your work on this, you would just multiply this out and make sure you get the original back. X times x is x squared. X times plus 5 is plus 5x. Minus 6 times x is minus 6x, so you get minus 6x plus 5x is minus x, and negative 6 times plus 5 is minus 30, so it checks. And then once you have it factored, you can use the zero product property. You know that x minus 6 equals 0, or x plus 5 needs to equal 0. And we get x equals negative 5 or x equals 6. And then we need to check to actually make sure that those work in the original equation. So we're going to check x equals 6. So run a check on it. So I got negative 3 on the left equals the square root of negative 5 times 6 plus 39. And then this is minus x, so minus the 6. And then you see if it works out, equals square root. Negative 5 times 6 is negative 30 plus 39 minus 6, so we get negative 3 equals the square root of 9 minus 6, so we get 3 minus 6, and we get negative 3 equals negative 3. So this guy checks out, and then we run a check on the 5, so we get negative, so this is for x equal negative 5. We'll run a check here and see how it works out. So I get negative 3 equals the square root of negative 5 times negative 5 plus 30 plus the 39 that was already in there, and then it's minus negative 5, and then we just grind through and see what happens. We get 25 from here. Negative 5 times negative 5 is 25, plus 39 is going to be what, 64, and we get a double negation here, so this is plus 5, and the square root of 64, the square root of 64 is 8. 8 times 8 is 64. We get 8 plus 5. We get negative 3 equals 13. So what we actually see is this isn't a true statement. Negative 3 doesn't equal negative 13. So all the way through we have the two sides not being equal. So we have to throw away negative 5 as an extraneous solution. So the solution is, after we throw away the extraneous solution, x is an element of the set that contains just a 6.